So how's it going, guys? Welcome to another Cool Tool Tuesday. So what I'm going to show you guys here is I have an interesting project. This is going to be kind of a combination project and cool tool video here today. So what this is a VFD. So what that does is it allows us to take a three-phase motor and adjust the speeds on it. We can make it go slower, faster, and you just have more control over it versus changing pulleys and that kind of stuff. So what I'm using this on is I bought a old industrial bandsaw that's three-phase. Problem is the shop I'm in here only has single phase. So the cool thing to do with these is you can feed these single phase 240 and it will do some PFM, fancy, pure friggin' magic stuff, and it will turn that single phase into three phase. So that means you'll be able to operate your three-phase equipment in your shop that only has single phase. So we're going to put this project together. So what we have here, this was kind of a pricey one. This isn't your cheap Scamazon VFD drives. It's a lens drive. There's the model of it. There's the specs, if we can see that. So yeah, the goal of this is to put this on a welding plug. So this is going to be fed off the welding plug. And this is going to spit out three-phase, 60 hertz at 208 volts. And run that saw. Now, how I'm going to do this is I'm not going to be playing with the forward reverse function or the frequency drive. As of right now, we're just trying to get three-phase to run this motor. So what I'm showing you guys here is we're going to do a little bit of theory on how this motor driver will be able to take power from the welding receptacle and power my three-phase saw. So this is how I'd explain it to an apprentice. This is by no means a technical overview on this drive or any other drive. If you need a technical overview of how it exactly works, go look it up by whoever you buy yours from. So this is how I would explain a VFD to an apprentice. So out of our panel here, so I first did it with some hand scribbled drawings here. This piece of paper, but I figured I could do it better for you guys. So this is what's coming out of your wall right here. So you got your panel and you got your split phase circuit. So it's called single phase even though you got two hots, because back here on the transformer, they tap the center of the transformer and get your neutral. So where we're getting our 240 volts. If you're to put it on an oscilloscope, this is how you would see your 240 volts. So what our VFD does is it takes that 240 volts and it puts it through a full bridge rectifier and turns it into DC. So that's our AC going in, it comes out of here, goes to the load, turns AC into DC, direct current. And if you were to read that on an oscilloscope again, this is what it would look like. So you got your alternating current going this way, and it would take that and flip that to a positive, like this. And then they'll add capacitors, and they'll bridge the peaks to make it a smoother DC. Once it's taken it into DC, it will then chop it all up, do its PFM, which for any of you guys that aren't electricians, that's pure friggin' magic. That's what we do. And it takes that and it turns it into pulses. And it will pulse in a frequency as well as in a positive and negative direction, creating your sine wave. And it will adjust that for the frequency that you want, if you want to speed up or slow down that motor. So yeah, that's a quick explanation of how this is going to take single phase, chop it all up, turn it into three phase. Now let's take a look at that saw. far as cool tools go, here are these two wire stripper crimpers. Maybe I'll do a whole video on them, but these are a Snap-on brand, PWC S7ACF. Awesome. One of my favorite set of stripper crimpers for, you know, working automotive or tight stuff. Just great. A little bit expensive being the Snap-on brand, but you can find other brands that have the same style. On the old Scamazons or Napa, I think you can get them as well too. The Blue Point style has this hook jaw, kind of 90-degree jaw. This is really great when you're working up into a dash and you're putting on connectors or in a real tight space. It just works really easy. I'm not sure if this is the part number on it, but it's lasered in here, OTC 5950A. This one's made in Taiwan, and this one's made in Merca, USA. And these are just cheap furl crimps from the old Scamazon. But if you're doing stranded wire, these are kind of the bee's knees for that. Then you don't get those little hairs sticking out and short-circuiting on the terminal beside it. So with this, the connections are very straightforward. The center here, we have our earth or our ground. Then we have line 1, 2, and 3 for our input. So seeing that we're only given it 240 volt single phase, we're just going to be using line 1 and line 2 and not worrying about line 3. So that's for our input side. Click. So you want to make sure that you're doing these to the proper torque specs. They're listed in the manual. So what I'm using is German torque specs, and that would be Guten Tight, yeah? So now for the motor side, we just have a U, V, and a W terminal for our motor. And we are going to correlate it with red, black, blue. So a little tip with these type of terminals here. Here, I'll pull this one out so we can really take a look at it. So this type of terminal, So it's a screw with this square washer that grips onto the wire. So one of the tricks with this is when you put the wire on, you want to always put it on the right side of the screw. Let's see if we can show you that. Yeah, there we go. So it's on the right side of the screw. And what's going to happen as you twist that screw down, that washer is going to naturally want to spin to the right this way, which is going to push that wire up farther into that terminal. If you put it on the left side of the screw, which you can do, there's nothing against doing that, but as you're trying to torque down that terminal, that screw, that washer is going to spin to the right and try to push that piece of wire out. So just makes life a lot easier if you go in the direction of the screw. Click. There we go. So let's zoom you out here. So there we have it. We got a VFD wired with single phase 240 in, and it's now gonna push out 3-phase. Biggest thing when you're stripping this cable, what I always do is I bend it like this, and I just softly score it with a knife. Because I've been to too many service calls where you're fixing a piece of equipment, and the reason why it had a fault or the cord end blew up is because it was nicked right there from the guys cutting too far into that insulation right there. They have to get angry like it like that. So this one's our 3-phase plug. When I'm stripping these wires, I'll give these a twist before I jam them in the cord end, and that just helps it from not fraying out before you terminate it. So after you get these covers on these Cooper welding plugs in particular, what I always do is I take my pliers and I'll grab these prongs and I'll make sure that they're set, because there's a little indent that they sit in on the backside here, and they don't always line up, and they'll make the cover kind of all cattywampus and not sit properly. And if you just give them a wiggle around with your pliers, it usually resets them, and then you just finish snugging up your receptacle or your cord end. So that's about as difficult as this is to turn a welding plug into a 3-phase plug for your equipment. So next what we'll do is we'll go dig out the old bandsaw and we'll go fire that up. Stick around. So Dad helped me dig out the saw here. So I got this saw from a guy who kind of collects industrial tools, and it was kind of sitting in his backyard, and I got it off of him. As of right now, I was wanting to show you guys how to run it, but it needs some work. It's leaking hydraulic fluid, the hoses are broken, nothing's powering on. Could be a limit switch, could be a fuse. I opened up that panel down there and there's some fuses and stuff down there for it. But yeah, this is the VFD for this, and it does work, but the saw don't. So anyways, getting this working will be a project for another day, not today, because I want to go back in there and continue welding on those rocker panels for you guys. More so for myself, but I'm going to bring you guys along. So yeah, follow this one for the next build project, I guess. See you guys later.